So, welcome to my channel. My name is David. I'm an electronic student engineer, and I was thinking someday why not share some interesting facts of neuroscience and some part of my routine. In this type of video, what I expect you is like a radio. It is me choosing your lo-fi playlist, and sometimes I'm here to share some good information and to share just like what I am doing. If you like, I appreciate it. Let's go. So, at first, to give some information and context, what I'm trying to do now is correct some part of my code that simulate an error. Yes, we can model and simulate almost everything, and in neuroscience it is specifically more difficult because this model it is non-linear, like the most part of the nature. So I use the Hindmarsh Rose model to neurons, and there is some situations for neurons that we are interested in see and understand how they will like react to give more context. Like I have the situation 1 that I have one neuron here, B is another neuron, and I have a lot of neurons until I have it is better that I enumerate. So the first one here, the second, and here we have the neuron 10. Okay? In this situation, you need to understand that your how I said it. but it's very close to Portuguese. So your nervous system, your nervous systems are interconnected by a lot and a lot of neurons. And this connection has some peculiarities, giving some good advanced in our talking. What you need to understand to what I am doing here is that I have 10 neurons connected, and this guy here, this one first, are sparking. I say is shooting. He had energy. It isn't a good way to explain it, but it is the easy way. He had energy. And this guy here, the number 2 and the number 10, not have the energy. Like a neuron and all your nervous systems, they are connected, and in this case, the information of energy and the excitation of the neuron 1, it is passed, it is transferred, that is a transfer, yeah, okay, it is just transfer. There is a transfer of energy between number 1 and number 2 and so on. Number 3, number 1, number 0. But when this number 1 are energized and influencing number 2 and the other neurons, we say that these are shooting neurons. They are here. It are giving some shootings, some peaks of energy like this. And for neurons, this is communication. It's very strange and a lot of, but trust me, this is cool and it is very difficult to me explain it in another language. But I can show you how I am doing for now. In summary, I have 10 neurons. The first one have energy and the others don't have. In the second situation, it is different. I have the first one. I have the same structure of 10 neurons, but all 10 are energized. And these situation 1 have one question. The energy that we have here came to here. this guy here will be energized sufficiently to shoot then another neuron here connected to him, connected to it. That is a question. This is a question, but this here, we know that all then will be shooting. All then have energy, sufficiently energy to be shooting and to be to do its sparks. We say sparks. This is like this is the time, and this is energy. This is very it is an easy way to explain it. Just give me some some space here to explain the easy way. So this spike of energy, it is how we say spark. So the question here is, each neuron are connected to other in line, and we have a variable here named A that is this word, I don't know. Coefficient. Coupling coefficient. Basically, coupling. Okay, so this here is a variable that measures the coupling of these two neurons. And we have another one here between two neurons, and another one. The question in the second situation is, how they will react to different values of coupling. Okay, different values of coupling. So we will test 0, 0.1, 0.2, and so on to 1 in the final. 0, it is completely disconnected, and 1 completely connected. I will try to obtain some results here, and I will share in the final of the video some images that is more clear to understand when we see image. And I admit that I take a long time trying to explain some specific parts of the search, but it is actually what I am studying. And obviously, in this video, I'm trying to improve my English too, and it is part of the all these contexts. I'm studying a lot of things. So let's back to the lo-fi. I'd take more time than I think it. Okay. Apparently, my notebook don't is good enough to support one life, and at the same time some code. Inside the code that I have 10 neurons. Each neuron have 10,000 points. And for each neuron, I compare the first one with themselves, the first one is with the second, and so on. For each of these comparisons, we do the cross correlation. This is my problem, because if you have the simpler form, the Pearson coefficient, we can did it in just 1 second or less. But the cross correlation is different. What is correlation at first? Let's say we have this signal here and the signal here. The correlation between these two signals is 0 because they are or 0, it is close to 0 because they are like 0 here, and here I have some value, 0 here and some value. The perfect correlation, it is the signal with itself. So in this correlation we have 1. Basically, in terms of synthesis, in terms of resume, correlation is it. It is an operation that we use to understand if two signals, how much two signals is, how much two signals seems the other. So the correlation is 1 if the signal is exactly the first, the second. And in this case of my project, if I have it here, I don't need to have 0. I need to have 1. Why? Because if we move this signal to here, some points, we will have the same one. So my array, my matrix are not so clean. We need to treat the information. We need to treat the data to put this information like this. The cross correlation and not the correlation is pick this, get this here, and move just a little bit to here and do the correlation. Move some point here, do the correlation again. Move some point, do the correlation again, and so on. The problem that I have is I am doing this for 10,000 points. So I have 10,000 correlations. And I have it with 10 processes. So I have 100,000 correlations between. So I cannot give. With my notebook, I will not have the result here. So it's better to use the Pearson correlation. The Pearson coefficient. That I just need to do one time. I will finish for here. Expect that you could see some of the process to learn neuroscience. In my case, it is a lot of Python, it is a lot of simulation, math too. I need to understand the basics of math to understand what is coring. So if I don't understand the cross correlation, I could not understand why my code is not running, and it is part of the process. Don't get the response one day. We just all the things going like good, and other days we have a lot of problems with correlation variables. To show you some of my results, I will kill the terminal here. For the end, to be more clear about what I am doing, here we have two neurons in that situation that I explained before. I have the first neuron that is the blue signal. This blue signal is the first one. You see that he is shooting consistently, and the other neurons are imitating. It is like the neuron 4, the green signal, it is trying to do the same thing of the blue signal. So this is the synchronization of two neurons. At the same time, the neuron 4, it is not energized. The neuron 0 are, and it is giving energy along the line of the neurons and pass information, and the neuron 4 are trying to imitate, to seamlessly trying to sing the neuron 0. This is one result of what I am studying. So we finished it here. I have a lot to learn and some configurations to do in OBS to improve the capacity of the notebook to work when I am recording, but at the same time, it's a good experience. I expect that you like it. Have a good day.